In this lesson, we're going to briefly discuss some things you can assume from diagrams and things that you should not. Also, review a few postulates. Add a few more to our tool belt here. Things that are just really are, for lack of a better term, obvious, and things that you can and should assume about any picture or anything you're seeing. They're often some of these are often referred to as what are called axioms. They're like the building blocks of geometry, and we're just briefly cover them there for this course. It's enough to just know that they exist and know what you can and cannot assume when looking at a diagram. Additionally, we're going to look at an application of angles and proportional thinking to analyze a problem, and analyze a situation involving an analog clock or clock with a face and hands on it, and decide and try to analyze a problem involving what the angle is between the hands of the clock. So we have a few warm-up problems here. I hope you've already attempted them. I'm not going to give space to pause the video because they're pretty quick here. But if you'd like to, you can go ahead on your own. But it says in these first two, state which postulate kind of justifies, or what's the reasoning, what reasoning would you use, and what seems to apply here. In this situation, it looks like I have angles that are adding together to be a bigger one. I think this is pretty clearly the angle addition postulate. And this at some point is between two others, then adding the two smaller segments adds up to the whole thing. This was the segment addition postulate. Find the measure of Mn if n is between m and p. Np is this expression, Mn is this expression, Mp is this expression. Let's draw a picture so we know what is going on. N is between M and P. So between means on the line segment that connects those two endpoints, M, P, and N is somewhere in here. Doesn't have to be halfway between, just has to be somewhere on the line segment connecting them. I'm going to label the things I know. From N to P is 6x minus 2. From N to P is 6x minus 2. From M to N is 4x. And from M to P is 16. So this whole thing is 16. With this in tow, I think with this picture, it's now much clearer of what to do. And I think that's, let's take the smaller pieces, add them together, and they should add up to the whole thing. So 4x plus 6x minus 2 is equal to 16. I think 10x minus 2 is 16. 10x is 18. X is 1.8, or 18 tenths, or 9/5. That in mind, we want to know what is the measure of Mn. So Mn is 4x, so I'm going to take 1.8 is 4 times 1.8, which is 4 times 1.8, just 7.2. We've already explicitly talked about two postulates, but we've kind of glossed over two others without stating them, but they were, I'll quickly recap what they are. We know the segment addition postulate is we talked about up here, is when you, if you have the smaller parts of a segment add to the whole thing. Same with the angle addition postulate. The smaller parts of angles add up to the entire angle. The ruler postulate and the protractor postulate, all they say is that you can use a ruler to assign numbers to the lengths of segments. So you can measure, essentially you can measure segments with a ruler, which obvious, of course, that's the tool you use. And the same game with protractors, in that you can use a protractor that's got marked measurements along it to measure the size of an angle and assign a number to it. So again, you can use tools to measure these things, and also that the sum of the parts adds up to the whole thing. Again, very, I think, straightforward and in some real sense obvious. There are a bunch of other things you can assume about about diagrams and pictures that I've listed here in this table. You don't need to have all of these memorized, but what you do need to know is that when you're encountering a situation, know what you can assume and what is on the diagram. Specifically, that if you have 2 points, then you can always draw a line through them. And moreover, and not only a line but a unique line. There's a single line that goes through those 2 points. And moreover, if you have a line, you can always put 2 points on that line. So it kind of works both ways. It's called they're converses of each other. 2 lines intersect, and what is formed when you intersect 2 lines? It's a point. Great. If you have 3 points, then you can always fit a flat infinite sheet on it. You can always fit a plane through any 3 points. And vice versa, if you have a plane, you can always find 3 points that are not all on the same line, that are non-collinear. Moreover, some other things about planes that you can assume, that if you've picked when you pick 2 points that are in that plane, if you draw a line through those points, then that line lies in the plane. I think obvious. The line doesn't leave the plane somehow. The line stays in that flat sheet. And lastly, if you take 2 planes and 2 planes cross, what do they form? They form a line. So again, you don't need to have the names or the numbers of these postulates memorized. That is not the purpose of this. But you should know when you're looking at a diagram what you can conclude and what you're not allowed to conclude. To kind of summarize and extend the idea of what you can conclude and not from a diagram, here's a kind of a quick summary of things. Things you can conclude. Like on this picture, is that all points shown on this particular picture are all on the same plane. They're all coplanar because they're all drawn on the same plane. So that's something you can assume in this picture. These are all coplanar. You can assume that things that look like straight lines are in fact straight lines. So that if angle AHB, and its partner that's making a straight line should also be a linear pair. So if AHB is an angle, then AHF make it a linear pair. You can assume that if it looks like 2 lines are intersecting, then those are in fact lines, and that angles that you think are vertical angles. So AHF, so this angle here, is definitely, since these are 2 straight lines that are intersecting, then the angle opposite of it that makes the opposite rays with it, BHJ, are vertical angles. They are angles that are opposite of each other, made by intersecting lines. Since we're assuming this, since you're allowed to assume lines, objects that look like straight lines are straight lines, then A, H, J, and D are all on the same line. They're all collinear. And lastly, if 2 lines intersect, if it looks like 2 lines intersect, or they definitely intersect on the page, then you can state the point that they intersect at. So line AD and BF definitely intersect at point H. So things to contrast that, things you should not assume. You should not assume that G, F, and E are all on the same line. They might look like it, but if there's not a line drawn through it, like the points above, A, H, J, and D, if there's not a line drawn through them, through 3 or more points, you should not assume that they all lie on the same line. That is not allowed. Further, if it's not drawn in that 2 lines actually are behaving a certain way, whether they're actually intersecting or not intersecting, you can't assume either one. One of them is going to be true, but we don't know which one. So, for example, CE and BF, it kind of looks like they might eventually intersect, like down the line. But I don't know if I was just kind of bad at drawing this, and maybe it's an optical illusion. It maybe BH and CE never intersect. Maybe they're parallel. It's not exactly, it's not clear in this picture that's exactly what's happening, and if it's not clear that's what's happening, you cannot assume either one. we can't just eyeball that angles happen to be the same size, that we don't have a justification for. So like BHA and CJA, that would be this angle and this angle. Unless you have more evidence as to why they need to be the same size, just because they might look close to the same size, or that we can't assume that they are. There might be justifications of why they could be, and we're going to see some reasons, some reasons why they might be or might not be in future units, in future lessons. But unless you have more information just by looking at this picture with nothing else, you should not assume that they are the same size. And to that end, you should not assume things are 90 degrees, angles are 90 degrees or perpendicular. Again, unless there's more information, unless they're marked perpendicular with the right angle symbol, or there's some other additional information that would claim why they have to be perpendicular. But as is in this diagram, you should not assume that anything that kind of sort of looks like it's 90 degrees is in fact any measure, let alone 90 degrees.